all the LEDs are connected through common ground.
Okay.
Okay, like we did for LEDs when we connected it to port 3. We were giving only one ground and all the LEDs were connected to some particular port pins.
Yeah.
Okay, if we connect 8 LEDs also, we need not connect 8 grounds. One ground in common is enough. As it is common cathode, here you can see the LEDs here, A, B, C, D, E, F, G, and 2 pins are there for ground. They all are common ground. Okay. And when you say common anode, the positive terminal has to be connected to VCC, that is 5 volts.
Okay.
Okay. That means what? When you are saying common cathode, our LED will work only when we give high, because commonly it is connected to cathode. I mean ground. Commonly it is connected to ground. So one side, when it is connected to ground, for our LED to work, we need to give power supply.
Yeah.
Right. So when we give, that means what? When we are in common cathode, to turn on an LED, we need to give 1 through our port pins.
Okay.
Okay. When we give 1, already 0 is there at common ground. So here we will have a closed circuit of your anode and cathode, and our LED will glow. When you say common anode, already it is connected to VCC. So we need ground to make our LED on. So when you are working with common anode, our port output has to be 0. When you give a particular pin 0, our LED will start working to glow.
Okay.
Because VCC is already connected. So we need to connect ground. So that ground we are giving it through port pins. In common cathode, we are giving power supply from there, and we are giving ground from common cathode. Okay, so if you want to write it down, so how we are going to write it down is, right. So here when we are writing 1 in common, first we'll see with common cathode, and then we will see with common anode. When you want to have 1, as we have seen yesterday, we will have to turn on 2 LEDs, which is your B as well as C, right? To display 1. Yeah. So in common cathode, we have to give this B and C value as 1. And I said you that here it will start from G to A, not from A to G. So here we will have some, okay, I'll just write that down. I'll not give, say, okay. Okay, G, F, E, B, C, B, and A. Right. Now these are like 7 pins, right? So 8th pin, as we are using common cathode, has to be 0. Because we have 8 bits. So basically we will be giving it like 0. So when we are writing 1, so now what happens is when you write 1, we have to turn on 2 LEDs, and that is B as well as C. So in place of B and C, we will write 1, and rest of its bits will be 0. 0, 0, 0, 0, 0, 1, and 1, and 0. So this equates to 0x. This, as we have to give it in hexadecimal value, the value becomes 8421 is 0, and next 8421 is your 3. So it becomes 0x03. Okay. Similarly, I'll just to show you 2 to 3 values such that it is simple for you. Now, when we are writing 2, we have to turn on so many LEDs actually. We have to turn on A, B,
G, C,
E. C is not required, right? 2.
Okay. I thought that is.
A, B, G, E and D. So here it becomes like H is not required, so this value becomes 0,
0,
G is
1,
1, F is
0,
0 again,
1,
E is 1, next
1,
D is 1, right?
0, 1,
C
1.
0, and then A and B 1 and 1. So this equates to your 1 and
5.
1. So this is 5, and the other one, these are 7 values. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this becomes 5 as well as 0, 8.
11.
This is 5 and 1, 0, 1,
B.
1. D.
B.
Huh?
B, right?
B, yeah. 5B. Okay. So in this way we will have to find the value. But if it is common cathode, common anode, same thing reverses. Okay.
Okay.
In place of 1 we will have to give 0. In place of 0 we will have to give 1.
Okay.
Okay. So it becomes 1, 0,
0,
1.
0.
Next to two values has to 0, 1, 0, 1, 0, 0, 1, 0, 0. This is the value if we want to give for 2 in common anode.
Okay.
Okay. So this equates to, we will write both and we will see. So this becomes 101 again, which is A, and the other one is 4. Okay, so this equates the value to 4. Okay, so this is where we are going to write it for. We are giving the values through port. These values will be giving it as port values, port pins.
Okay.
Now if we write one program and we will see, we need not mention that we are going to write a program for 7 segment, because basically your microcontroller doesn't know, but what we are giving it as output, that does matter.
Okay.
Did you download this keel?
Yeah.
Okay. Okay, so now we will write one. Okay, first we will have to write one delay function. Why? Because without delay we will not be able to see the values, it will go so fast. So I am writing one delay function. I'll show you one later on. I'll just say you how to create library, such that when you write once that library, you will not have to write this delay function and again. Like we can simply call this delay function, like you are including reg51.h. We can create one library for delay or any other functions, and we can initialize it. I mean, simply we can call it.
Okay.
Like we are calling printf and all. But for now, if it is better to write it down.
Okay.
Because we should know, otherwise we'll forget it.
Yeah.
Jail. Okay, this is our delay function. I am declaring and defining it at same place, so there is no need of writing it again. So now I am writing my function. So here I am using common cathode.
Okay.
So I do have some values already. We'll connect it at port 2 equal to 0x 3f. 3f is nothing but 0. Okay. Why? Because all LEDs has to be 1.
Yep.
Right. That's why I'm giving it like 0, and then we write it like delay of delay. And then we have written this value 0x 0. Oh, sorry, this is not 3, this is 6. 4 and 2. It is 6. And we'll write it like port 2 equal to 0x 06. And again call delay. And 2 is 5B, I guess. 5B. So I am writing it only for 3 values because we have not written more values. We have not found out all the values, so I am writing only 3 values. Now we will save it and we will compile it. So here you will not be able to see anything. It created my hex file. If you want to see our output here, we can simply check at port 2 that we'll get these 3 values. So 3f, and it is giving me delay, so I'm simply running it 065B 3f. Okay.
No.
Okay. So I'll stop this and then I'll connect. Now if you see this, we will have to connect our A at, as I said you, here we are writing it from G to A.
Okay.
Right?
Yeah.
Eight, 9. Segment display, and here we have 7-segment common cathode I am taking. Sorry. So if you see this, I'm just connecting it here. We can, in terminal, we can find ground. Just click on ground and connect this to ground. Dump here hex file. each and every microcontroller, depending on company, will have different IDE for writing programs. Okay, when you say 8051 or it is related to ARM, you are able to use Keel software. If you are using something like AVR, you will have Atmel Studio. If you are using PIC controller, you will have MPLAB IDE. If you are using STM controller, you will have OpenSTM32. So depending on what, if you see, you are able to see this?
Yeah.
Yeah. So this is how we need to write our we are simply, what we are doing is we are giving output pins, that which pin has to be 1 and which pin has to be 0.
Okay.
Okay, so if we are controlling it through giving our port output.
Yep.
Okay, and same here also, you are not supposed to connect it directly without resistors. We need to connect it to protect our device.
Okay.
Okay, so I suggest you to write down one program for like just to start it from 1 to 0 to you write one program for 7 segment to display from 0 to 9 and then from 9 to 0. Okay, and one more program for connect a switch or button. Connect a switch. If you click on switch, if switch is equal to 1, it should display from 0 to 9. Okay, and if switch value is 1, 0, it has to display it from 9 to 0. Okay, and one more thing, I want you to connect 2 7-segment displays.
Okay.
Okay, at 2 ports, connect to 2 7-segment display and display from 0 to 99.
Okay.
Okay, just 2 displays you will have to use for loop there.
Okay.
Okay, don't change the value of first display and change the continuous value of second display. After you display that, then change the values when second display displays from 0 to 9 and then you change the value of first display.
Okay.
Okay, you got it?
Yeah.
One display has to be constant for 9 values of second display.
Okay.
We will have something like one more, if you generally what we do is we don't go for this single display, we will have multiple displays in one screen. Okay, and that too it will have something like common pins. How it will be is, if you see this, I'll stop this and I'll show you one device. 2-digit, 7-digit, 2-digit displays. See this, if you are able to see this, you will have this 2-digit common anode, 2-digit common cathode display. If you see this here now, how to connect this, you don't have two pins, right? You are not able to connect it at 2 ports.
Yeah.
You are able to see this? You have only one set of A, B, C, D, E, F, G.
Yes.
And you have 2 extra pins called 1 and 2.
Okay.
Right. So here what you need to do is you will have to give it like select 1 or 2. 2 pins are there. So to activate that, we will give it, this DP is nothing but decimal point. Okay, last one LED, round LED is there. This DP is for that LED.
Okay.
Okay, so ABCD EFG is for 8 LEDs and DP is for this point. Now here 1 and 2, you will be connecting it for only this pins, but the last 1 and 2 pin will select whether you want to display it on first display or second display. Okay. So when you activate at a time, you can't turn on both. Okay. Or you can. Actually only one will work, but if you want to try, you can try. So you will be giving that pin like 2 more pins, you will be connecting it to 1 and 2. You will be turning on one display at a time, and you can display 0 to 99.
Okay.
Okay, one display you select, give one value, and then change the second display value continuously. Then again select one, change the value, and give access to second pin. You try it out. If you are not able to do this, I'll do that. Okay.
Okay.
You will have to power up. Basically, you will have to power up 1 or 2. You will have to. These are, you can call it as select lines.
Okay.
Okay. So this is about your 7-segment displays. With 7-segment displays, you can do so many things. You can do many programs or anything. And common anode, I suggest you start with that.
No.
LCD display, like we have 7-segment display, we have LCD display also.
Okay.
When we say LCD, here we have 16 pins for LCD display. I'll show you 1 second. This is the pinout for LCD display. You're able to see this?
No. Only I'm seeing the notepad.
One LCD display is there for 16 by 2 pin. Not now also?
No. Only seeing that notepad.
Okay, maybe. Just a second. Now you are able to see this?
Yes.
Okay, so this is your 16 pin pinout for your LCD display. So here, what are these pins again? If you want to display something on your LCD, you will have to connect these 16 pins. Okay, in this, these 3 pins, first 3 pins are for power supply and ground. Okay, this VSS is ground. First pin is VSS, which is ground, and VDD is your 5 volts power supply. First 2 pins we leave it. Third pin is to display or to control the contrast of your display. In general, you will be having yellow background or green background with black color characters to display.
Okay.
So what is the brightness of that? You can control it through this third pin. You will be connecting a potentiometer or any resistor for which you can change the value. And by adjusting the resistance there, you will be able to connect, make it contrast, and that you will be connecting it to 5 volts. This VE pin, we will be connecting it to 5 volts with potentiometer or any other device where we can change the resistance for. So by changing the resistance here, the contrast of that will change.
Okay.
Other than this, we have here 3 pins called RS, read and write, or enable.
Okay.
Okay. RS is for whether you are going to here to display anything on LCD. LCD is basically liquid crystal display. So when you want to display something on it, you will have to give the commands.
Okay.
Okay. So, and 2 things will be there. One is command and the other is data. What you want to display is data, and how you want to display that data has to be given through commands.
Okay.
So whether you are giving commands or you are giving data, that will be selected using this register select pin.
Okay.
You will have to make it 1 or 0. When you are giving RS is equal to 0, or you are making this pin as low. 0 is low, 1 is high. So when you are making this pin as low, it will take whatever you give as command.
Okay.
And when you are making it high, it takes whatever you give as data. So when this pin is high and you are giving command, it will consider it as data.
Okay.
Okay. Then you have one more pin called read or write. Whether you want to use mode of reading or writing. If you want to write into, when you want to display something, you will have to write into LCD.
Okay.
Okay, when we are going to send data, then only it will display it, right? So when we are sending it, we are nothing but we are writing it.
Yeah.
Okay, so whether we want to use it for write mode or read mode, we will have to select through read or write mode. And the last pin is enable. Sorry, sixth pin is enable. So here we will have to make it high to say that allow the data or command to LCD.
Okay.
If we don't make this high, neither it will take commands or nor data. It's like a switch. When you make it on, then only it will take commands or data. If you don't make it, if you don't turn it on, it will neither take commands nor data.
Okay.
Okay, and rest of the pin again from 0 to 7 data pins. Here through these pins only we will be sending commands or data through our port, which we will be connecting to one particular port.
Okay.
Okay, and as this is your LCD, so here you will have some LED positive and LED negative pins which we have to connect it to power supply and ground to display the data on LCD.
Okay.
Okay, so these are the pins which we have for your LCD. Now coming to how to and what are the commands do we have. You're able to see notepad?
Yeah.
Okay, so what type of commands we will have here? We will have some commands like, for one of the commands is 0x01. So this command, what it will do is, it will clear the screen. So whatever you have on your LCD, if you want to display the second data or second set of data, so first you will be displaying something like welcome, and after that I want to erase that and I want to display it like embedded systems. So first, if you want to display it, if you don't want to overwrite and if you want to clear the screen, you will be using command like 0x01.
Okay.
Okay, next you have some command called 0x38. Now what this display is for, what this command is for is, this is for display the data in 5x7 matrix form.
Okay.
Okay, now why we will use this? If you see this LCD screen, okay, I'll not be able to. One second, I'll show you whether we are able to see in this or not. I don't know. I'll just try to show you.
Okay.
Here you can see 16 by, we will have various LCDs. Here we have 16 by 2 graphical LCD, 16 by 2 I2C, connected through I2C. Here it will take only 2 lines. We will have something like 128 by 64 LCD, graphical LCD. So many types of LCDs are present. We are right now we are using only 16 by 2 alphanumeric LCD. Okay, in graphical LCD you will be able to display various graphics in it. But in 16 by 2 alphanumeric LCD, you will be able to display only alphabets, numbers, and some special characters like question mark or double quotes, general special characters you will be able to. But when you say graphical LCDs, you will be able to design your own thing like some animated thing. If you want to display, you can go for graphical LCD. Okay.
Yeah.
But when you use only alphanumeric LCD, it will display only numbers, alphabets, and some special characters.
No.
So we will go with this 16 by 2 alphanumeric LCD. Now, Okay, in this also I will have to power it up. Okay, I'll show you what happens when you say 5 by 7 matrix form. Here, this, okay, when you are displaying something in LCD, each character is divided, if you can consider dots. 1 minute.
Okay.
1 minute, I'll just show you. When you say 5 by 7 LCD, it will have something like this.
Okay.
This is 16 by 2 LCD. That means in each line you can display 16 characters. 16 by 2 means 2 lines, each line 16 characters.
Okay.
Each character will be displayed in this format.
Okay.
Again, that means each character, whatever space is given, it is divided it into this 5 by 7 matrix form, and whatever you want to display, it will be displayed in this way.
Okay. Yeah.
Okay. So
Yeah.
this is why we gave it like 5 by 7 matrix form.
Okay.
You understood what I'm saying?
Yeah,
Here
yeah.
you have 16 characters displayed in each line. That's why you are calling it as 16 by 2. And each character will be given one particular space. That space is divided into this 5 by 7 matrix form and displayed. All the characters will be displayed in this particular 5 by 7 matrix only.
Okay.
Okay. So this command is for 5 by 7 matrix. Next you have some more commands like 0x0e. This command is for whenever display is on, make cursor blinking. So whenever your display is on, continuously the cursor will be blinking.
Okay.
Okay. Then you have commands like 0x80. Now I want to display something on LCD. I have 16 characters I can display, but I don't want to display all the 16 characters. I want to display my welcome in between. That means I want to start it from 5th character and end it at 13th character.
Okay.
So I am not using first 3 spaces and last 4-5 spaces I am not using. I am using only middle portion of my LCD. And
Okay.
that too only first line.
Yeah.
Okay, but that has to be set to my LCD. That I am going to use only first line and 3rd character place. Okay, so how to say that? 0x80 is the address given for first line and first character.
Okay.
First line, first position. So that position we will have to give. That means what? Now first line, first position is 80H, right?
Yes.
Second position is 81. Third position
Yeah.
is 82. So 16th position is 8F.
Yes.
Right. So automatically 0x90 is for second line, first position. Right.
Okay.
But it
Yes.
is not so. It is not. Why? Because this comes in variant like 16 by 4, 16 by 16 by 2 and 16 by 4. So
Okay.
this 90H is given for second line. Here the second line will have address of C0 and not in 90H. Okay, because 16 by 2, 16 by 4, then you will have something like 32 by 2, 32 by 4. Various LCDs are available.
Okay.
You have already seen this here in Proteus, that you will have so many LCD displays. So particularly these LCDs are given. Now if you see this 128 by 64, if you see only alphanumeric LCD also, you will have 16 by 2, 32 by 2, 40 by 2. These many variants are available for alphanumeric LCDs. So we do not get confused every time, or we need not calculate it every time. What they have done is the second line address for 16 by 2 is given as C0. Okay, that means you will have something like 80, 90, A0, B0. In between you have more 40 spaces available in between for big displays. Or you can say I can have 32 by 2 also. So when you say 32 by 2, you are able to display 32 characters on 2 lines.
Okay.
Right. So at that time I can't have C0, a 90 address for second line. So to not get confused every time, we have second line address as C0 with first position. So here the address will be from C0 to CF.
Okay.
As it is for 16. You got my point here. If you have 32, 17th position will have the position address of 90.
Yeah.
Okay, if you have 32 by 2 LCD.
Okay. Yeah.
Okay. Next you have some commands like some more commands. But this is, we will see if it, whenever it is required, I'll say you more commands. But for now, these many commands are enough. So these are like commands. Now what is like data? When you want to display something, simply give it with single quotes format. Okay. Normally characters we will give as data.
Okay.
Only direct characters we will give here with single quotes or double quotes in program itself. No need of giving it with something like commands you are giving. No need of giving it like this. Directly we can give.
Okay.
It can be anything like A, B, C, anything you can give. That we will be writing it in program.
Okay.
Okay. So you are clear about the pins and this commands? Are these okay? Right. Now, so first we'll start with our program, and then I'll show you eventually how we are connecting these pins and okay. Now first of all, I will copy this. Okay. I'll just copy our delay function from some other function. Otherwise again I'll have to write it down.
No.
Okay, so first what we are going to connect. Okay, so as you can see here, what we need to connect is these many pins are there. Okay, we will connect D0 to D7 RS RW enable, right?
Yeah.
Okay, rest of the 5 pins are connected either to ground or power supply. So
Okay.
we need to connect only these 11 pins to our microcontroller. Out of 16 pins, only 11 pins will be connected to microcontrollers. The rest of the 5 pins are connected either to power supply or ground.
Okay.
Okay, so we have one port we can dedicate for data lines.
Yeah.
Right? We will be dedicating one port for this data line. So I'll be connecting something like port 3 for data lines.
Okay.
Okay, and RSRW enable, I'll be connecting it to port 2, 5, 6 and 7 pin.
Okay.
So every time rather than using this, I'll declare something like SFR and all. So I'm declaring my special function register, and I'm making my LCD port pins which we are connecting to port 3. So I'm giving SFR and I'm naming it as LCD and giving the address of port 3. So port 3 address is B0.
Yeah.
Right, 0x B0.
Okay.
Right, next we are connecting some RSRW enable. So I'll declare that also, rather than writing every time P3.5, 3.6, 3.7, I'll name it one pin. I'm naming it like RS S bit, and I'm naming it as RS, and I'm connecting it to P3.5. Okay. Similarly, I'm connecting your RSRW pin, which is read or write pin, and I'm connecting it to port 3. Oh, not port 3. Already we have used port 3, right? We are connecting it to port 2.
Okay.
Port 2 5th pin, port 2 6th pin, and last one is your enable pin, S bit enable, and we are connecting it to port 2 7th pin. Now this is our declaration to connect these 11 pins to our LCD. Okay, and now we will be writing delay function. So I am declaring, already I have defined the delay function, so I'll declare my functions here. I am declaring delay function here, but this delay function we will give it with user defined delay. So I am giving it like unsigned int. So here it becomes unsigned int t, and here I'll give my value. Right?
Okay.
Okay, so this function is over. Now I'll write my main function, and then I'll write my other functions. So here, first of all, now first thing what we need to do is we need to initialize our LCD, right?
Yeah.
We need to initialize your LCD, that how you want to display the data, where you want to display the data. So what I'll do, I will have to pass some commands, like I will have to say that display the characters in 5x7 matrix form.
Okay.
I will say that display cursor blinking or display off cursor off. Like these, some more commands are there, which I'll say you just a second, 1 second.
Okay.
Just a minute. One second, I'll say. You're able to see this?
Yeah.
Okay, so these are some of the commands you have. Like I said you, this is 0x01 is for clear the screen, 0x30 is to say 0x30 and 38 are to say that 5/7 dot lines. I mean matrix
Okay.
form.
Okay.
Then you have, this is for first line and this is for second line, but if we give it for okay, first this is for only one line and the other is for 2 lines. Then you have the for 4-bit mode, this is for 8-bit mode.
Okay.
We are using 8 bits, right? So this is for, this function set is for 8-bit mode. And if you are using only 4-bit mode, then you will have to say this using 0x28 and 0x20. Okay. To say that display the characters in 5/7 matrix form. Next, you have some command mode like 0x, this is entry mode to start the LCD. 0x08 is for display off, cursor off. You will not be able to see the cursor.
Okay.
0x0E for display on, cursor on.
Okay.
0x0F is for cursor blinking, display on, cursor off. These 4 commands is to basically whether you want to backlit light will be there, which is display off. Otherwise you can say that when this display off and cursor off, that means LCD will be on, but you will not be able to see anything on your display.
Okay.
Okay, so that you can do using 0x08 command. Then you have, if you want to display shift entire display left or right, which we generally use to scroll.
Okay.
We go for 1.8 and 1C command, which is 11th and 12th command. And if you want to move the cursor left or right by 1 character, we will be using 10 and 14 command, which we will see while writing programs. And 80 and C0 is the position for first line and second line.
Okay.
Okay, so these are the set of commands which we have. We have more commands also actually, but basic in general we use these commands. We will have like 0x02 command to return home, or then we have some more commands like 0x04, 0x06. I'll give you full list of commands depending on what LCD which we are using.
Okay.
Okay, that we will have to see what commands are available on the data sheet of that LCD.
Okay.
Okay, next, okay, so we were writing program now. So first of all, when you are starting your display, you will have to initialize LCD. In what way we are initializing your LCD is saying your display that display the characters in 5/7 matrix form.
Okay.
And whether you want to keep your display on or off.
Okay.
That comes under your initialization. So rather than writing initialization, I am just writing one function called initializing one function. I am writing one thing like initialize, INIT, initialize underscore LCD is one function which I am writing for initializing my LED. Okay, so same thing, I'll just declare it here. Int LCD underscore initialize underscore LCD. Sorry, initialize underscore LCD, and we will have to now define our function. So what we are going to do is we are going to give commands in this, right?
Yeah. Yeah.
But how we are going to give commands? We are going to give it through data lines, right?
Yeah.
And at the same time we need to give data lines. At the same time we need to say that whatever we are giving is command.
Okay.
Okay, so I'm writing one more function for this, which is like command underscore LCD. Okay.
Okay.
Inside this, I am writing one more function for command and data. So for I'll write one command and then I'll say you how we are passing it and how it will take it, like whether it is command or data. So first I'll declare this function again, and I'm writing one function for command underscore LCD, and we are passing one parameter inside this which is under 2. Our commands, all commands are under 255, so I'm writing it like unsigned char or int, your wish, no problem. And now I'm writing my function. Now if you are clear till now, tell me something that if you are giving command, what you need to say your LCD. First thing we need to say that we are sending it in command mode.
Okay.
We have to say that we are setting it in command mode, right?
Okay. Yeah.
So what I'll do is I'll make RS is our bit to set it in command mode.
Okay.
So in command mode, what I said, RS is equal to 0.
Okay.
So once you execute RS is equal to 0, it will take it as command mode.
Okay.
Okay, and then I will say that I want to write this command.
Okay.
So for that we have written RW is our pin. So I am making this pin as 0, and then I'll say enable.
Okay.
Okay, so before doing all these things, I'll do one thing and I'll say that assign this particular value which is unsigned char some t or unsigned char anything, data or anything. I'm just writing it like t, and assign this to my LCD. Okay. First I'm sending my data to my LCD data pins, which is port 3, and then I'm saying that whatever I'm sending is register is equal to 0, which means that this is a command and I am writing it into it, enable it.
Okay.
Okay, so this will allow your commands to enter into LCD.
Okay.
Okay, and then I'll give some delay, something like 10 milliseconds, and then again I'll make enable equal to 0, which means again I'm stopping my operation, because once I send, that's it, enough. I don't want to make it on every time. I mean, I don't want to keep it enabled, so I'll just disable it again. Okay. So whatever I have sent my command I have sent, now I am closing it. That's it.
Okay.
Okay, so now when you write in initialization command underscore LCD of 0x01, it will take it like LCD is equal to 0x01, and it is command, write it, let it enter LCD and off it.
Okay.
Okay, this is clear?
Yeah.
In this way, we will send some more commands. I'm giving 5 milliseconds delay for this. Some more commands, like already we have given only 0x0 is for 0x01 is for clear the screen. So I'll give it like 0x38, which is for 5×7 matrix form.
Okay.
And then I'll give it for next, what I want to give is I want to make my cursor on. Okay, cursor on and display on and cursor blinking. So I'll give one command called 0x0e, such that I'll be able to see my cursor. So these are my initialization for here LCD. So for initializing I am using command mode, and that's why we have written command function.
Okay.
Okay, now my initialization is over. Now I want to display something on my LCD. So
Okay.
I'll write it in one loop in my main function. Again I'll come to my main function, and here what I want to write. Now we have written command mode to write commands. So I need one function to display data also. Why? Because again I will have to write my rs is equal to 1 to take the data in to take whatever I am entering in data mode.
Yes.
Because I can't use my command function to take my data. Why? Because this rs, rw, enable, rw and enable are same, but this data, this rs is equal to 0 has to be changed to rs is equal to 1 for my data mode. Data is nothing but whatever you want to display on your LCD. Okay. Commands are already predefined, but data we will have to define it.
Okay.
Right. So I have to change this bit. So I will write one more function called data function. So here what I'll do is, first I'll declare it data underscore LCD or display underscore LCD or print underscore LCD. I'll write print whatever we are printing. It will be easy for us to understand. So we are printing something on LCD, and what we are printing is we are giving through here. So I'll take this function and we will write this function. I'll copy this whole thing again. So here again what we have to do, we are giving our data as well as commands through same data pins, okay, through port 3 only, but it will differentiate it with this RS bit.
Okay.
I have made this RS is equal to 1. So now whatever we are sending, that data is register select equal to 1 means it is in data mode. Write it, enable it, and then again disable it.
Okay.
Okay, so it will allow only one character when you make enable equal to 1 and 0.
Okay.
Now we have written our print underscore LCD. Now what we want to print and where we want to print. So I'll give again command underscore LCD, and I'll write that I want to display it at 0x80 position, which means first position, first line, and what I want to display is print underscore LCD. I want to display something like in single quotes I will write H, and then again one more I'll write. It will, when as we are writing after writing first position, so when you give another one it will automatically increment to next position. So when I'm writing I, it will be taking it for 0x81 position automatically.
Okay.
Okay, so this is my program now. If you have any doubt, you understood? Is it clear?
Yeah.
So you will not be able to display all these things here. You will be able to see this using only port pins. So what I'll do is, I mean you will be able to see 0x38 and all commands, but you will not be able to see the characters here. So I'll directly use this hex file, and I'll, if we have any errors we will check. If we don't have, oh, we have redefinition. What we have redefined here? We didn't redefine RS RW enable. We have so many errors. So basically here we have not given semicolon. somewhere, which is HF.
Top third line.
Oh, still we have these many errors. Syntax error near this. And what is the syntax error? Oh, sorry. As I have given this semicolon, it is taking it as again new characters. Somewhere anything else? Still 4 errors. LCD equal to T. See, these are local variables, okay? As these are local variables, these are local, T is local variable.
Okay.
Okay, when you are writing it like global variable, you can't, it will be changing. If you are using it like local variable, when you are calling this function, it will create this variable, and as soon as you exit this particular function, it will destroy that variable.
Okay.
Okay, so if you are using same name for different variable, it will not, it doesn't matter, because it will be created with that function and it will be destroyed with that function. Because
Okay.
I have used, it's not necessary, you should not use same variable, but just to show you that if you use even same variable, I have used this T 3 times.
Yes.
But these 3 will be created every time and deleted, destroyed every time.
Okay.
These are not common names. I mean common variables. These are not common at all.
Okay.
3 different characters, the 3 different memory spaces will be allocated with this name.
Okay.
Because these are local variables.
Yeah.
Okay. So now I don't think any error will be there. So written value is okay. My hex file is created. Now we will connect our LCD here. Did you download that? Did you see whether you are able to download it?
Yeah, I have downloaded whatever that file is there.
Sorry?
So setup with pass, the zip file is there, right?
Right.
I downloaded that. Okay.
Till I connect, if you want, you can just install it such that you will, if you have any doubt, I can just check it out. Now if you see this,
Okay.
okay, so it is displaying high, and why it is your cursor is again and again going to first position is because in our while loop we have given something like 80 position.
Okay.
Every time it is executing this 80 position. Okay, that's why
Okay.
it is again and again going to first position. If we write this command before while of 1, it will simply print LCD. I mean, it will display high, and it will keep the cursor at that position only.
Okay.
Okay. But what will happen is, if you do that, it will be a problem. What problem is? It is what I said is, when you print first character and then second character, the cursor is automatically incremented, right?
Okay. Yeah.
Now when you print it again, that cursor is incremented to third position,
Okay.
fourth position. That means on whole screen you will be able to see high.
Okay.
That's the reason you will have to give the command here.
Okay.
Now if you don't want to display that cursor, simply make that cursor off by giving a command called 0x0c. We have written display on cursor on. So
Okay.
in place of 0x0e, if we say 0x0c, our cursor will not, it will not display our cursor.
Okay.
Okay. So simply by doing that, we will be removing our cursor. Now when you want to display something like this, I want to display a big message. It will be very difficult for me to write like this. Every time 1111 character to give, it is difficult.
Okay.
Right. Here like this I have written print LCD underscore h. Print underscore LCD hi. Now when I want to write a big message, I can't write it like this. We will have to give it like a string.
Okay.
Okay, so for that also we have to write one function. If we want to write something like that, so what we will do is, we will write one function for print underscore string. Print string underscore LCD will be better. Print str underscore LCD, and we will be giving it like in double quotes. Write in double quotes because we are giving string. Okay, and I want to display this at second line. So command underscore LCD, and I am giving position of 0x C4. So it will be displayed at fifth position, from fifth position, sorry. So now as I have written print str underscore LCD, I will have to write one function for it.
Okay.
Right. So I'll declare that function first. Print string underscore LCD, and now as you are writing it like string, I am using pointers for it.
Okay.
Okay, so here I am giving unsigned char pointer p, and okay, you need not declare it here. Unsigned char, I'll write simply pointer, and I'll write my function. So now what will happen is, when you call this, your pointer p will point to E.
Okay.
Okay, so what I'll do is, I'll write like, while my pointer p is not equal to 0. Not equal to 0, not equal to /0. /0 is null character.
Null point. Okay.
Okay, so we will just check for null character. If till you get null character, your pointer P is pointing to E. E is not a null character. Null character is /0. Okay. Null character means nothing.
Okay.
Last character. Last means not last. I mean, when there are no characters left, you call it as null.
Okay.
So, if at all, if it is a null character, if it is not a null character, what I want to do is, I want to send that particular character to print_LCD.
Okay.
Print_LCD, and as we need to pass that to print_LCD, I am saying pointer P. Pass this pointer P to print_LCD. Okay, and then after doing this, increment your pointer to next position.
Okay.
Okay, so now what happens is, you are just checking E is not equal to null character. So what you are doing, you are sending this E to print_LCD.
Okay.
Okay, in this way you can send strings. So we have written that already, so we will simply run it. See. Okay.
Okay.
Right, and in this again we can just simply edit this also. What I am doing is I am giving the string here, right, and I am giving command also.
Okay.
Right, so in place of this I can simply write like this also. I can say here itself that I want to print something, and I can give my command here itself, 0xC4, comma embedded. I am passing 2 parameters into my print LCD function.
Okay.
Okay, if we do this, we will have to again change our function. Here I will have to give unsigned char, comma unsigned char pointer, because one is simply unsigned char and the other one is pointer, and in our print function also I will have to change it to unsigned char some r, comma unsigned char pointer P. So before starting to print this, we will have to give the position. So here I will write command underscore LCD, and I will pass this R here.
Okay.
So when you want to display it in this, I mean when you want to give command also in this same function, you can give it through function directly. This will also work in same way. Fine?
Yeah.
So basically, any device you connect, till now you have connected 3 devices, so basically you should know that your microcontroller doesn't know what you are connecting.
Okay.
Okay, but only by controlling our port pins, we are running those devices.
Okay.
What I mean is, we are giving data, but your microcontroller doesn't know we are giving data. We are simply making some pins 1 and 0.
Yes.
Okay, so your microcontroller or microprocessor will not know what you are doing.
Yes.
We will have to say it every time, and that too even after saying it every time in this particular microcontrollers. When you say microprocessors or your laptop, we will have to say what device we are connecting, because when you say your laptop, when you connect or laptop or desktop, when you connect your USB device, it will show you that some USB device recognized an LCD driver installing something.
Yes.
Right. So if you say those things, then already some predefined programs are there which has to be run to say that this device has been connected to this. But your microprocessor or controller or any other device doesn't know what it is. We are simply controlling any device, any inputs or any outputs through on and off, or making some particular bits 1 and 0. That's it.
No.
Okay, now I would like you to write or display something on your LCD. I'll give you list anyway.
Okay.
Yesterday's list also I will have to give you. I will give you some list, but simply display some 0 to 255 on LCD. And then you use switches. When you are using switch, what you can do is you can display, like when your switch is 1, display one set of statement. When you are using switch equal to 0, display some second set of statement. And you can use your LCD to work like counter also.
Okay.
When your switch is 1, display something like whenever you are clicking on switch, increment the number.
Okay.
And there only you can use another switch to show that I want to decrement it. So what I would like to do is to use 2 switches. Okay. And then when you click on first switch, it should increment like 1. Again you click on switch, it should increment 2. But when you use the next switch, if the value is 2, and if you click on that switch, it should become 1.
Okay.
Okay. So I'll say you one example, not example, but I would give you one situation to write this program. I would like to say that I want to control my lights. So here my lights will be LEDs.
Okay.
Okay. So depending on the number of people in the room, I would like to turn on my lights on and off.
Okay.
Okay. So if the number of, now you will need sensors for that.
Yeah.
Right. If a person is entering a room or exiting the room, we will need sensors. So here right now we have done only switches, so we will use switches for that. So you will use switches to find out that you will be using 2 switches. Okay.
Okay.
You will be using 2 switches to say that whether a person has entered a room or exited a room.
No.
Now when you are saying if you have only one door to enter and exit, how you will find out? So when you are entering, your first sensor will work first, and then second sensor will detect you. Right?
Yes.
Right. So if first sensor activates and then second sensor activates, that means a person entered a room. And if second sensor activated and then first sensor activated, that means a person is exiting a room.
Okay.
Okay. So same thing you will be doing using switches. Now your switches are your sensors.
Okay.
Okay. So if number of people in the room are from 1 to 5, only one LED should turn on. If it is from 6 to 10, 2 LEDs should turn on. It is from 11 to 15, third LED should turn on. That means 3 LEDs should turn on. And how many people are there in the room, the same thing has to be displayed on LCD. That means you will be using switches, LEDs and LCD in one program itself.
Okay.
Okay. And if it is like 15 people entered 3 LEDs, well, exiting the room, the same count has to be decremented, and if number of people are like 6 and one exited immediately, automatically it should decrement from wherever it is, not like it should go till 15 and then you should decrement it. No, anytime a person can enter and person can exit. You will have to keep count of that.
Okay.
You will try, right?
Yeah.
You are clear with this question? Actually, if I write it, it will be difficult for me to explain what is the situation. That's why I am saying you.
Okay.
You understood?
Yeah, I'll try to execute. If anything, I will tell you.
Right. Okay. So you will be doing this one also, and then next thing what we will have is I'll give you some more thing. But before that, now we will go to keypad. So we will write a program for keypad, and then we will see how this keypad is working. Okay. Now, when you are writing your keypad, keypad is nothing but group of switches.
Okay.
Connected in particular format. And we will have to scan for those switches continuously to find out that which switch has been clicked. Okay. Now, if you see how this switch will be, I will show you in this process. Okay, keypad. See, here is the keypad. This is for calculator, this is for phone, this is for small calculator, and this is for, and this is DLL model. So we will use keypad for phone, which means this is your 3x4 matrix form, right?
Okay.
This is 4x3 matrix form, 4 rows and 3 columns. Okay.
No.
Now how these switches are connected is, how we will find out first of all that which switch has been clicked, and how to find this. I mean, how to show you. See, just a second. How to explain this? I'm thinking actually. Because I don't have this switch connected pin diagram with me. So what we will do is, see, how we are connecting switch. One we are connecting it to ground, and one pin we are connecting it to some port pin, right?
Okay.
Right? Generally, how we are connecting a switch? We are connecting a switch in form like, one we are connecting it to ground, and the other we are connecting it to some port pin.
Okay.
Right? But what we will do is now connect all the pins in one port only.
Okay.
Okay. So first of all, we will declare all those rows and columns.
Okay.
Okay, and then we will scan for it. How we will have to scan, I'll say you that. But first of all, we will just see this, and I'll give you one First we will have to declare it. So here I'll call this 1, 2, 3 and A, B, C, D. 4 you are able to see, 4 rows and 3 columns. 1, 2, 3 are columns and A, B, C, D are rows. So I'll declare that as row 1, row 2, row 3 and column 1, column 2, column 3 and where I am connecting it. Okay. So here I will declare it using your S bit.
Okay.
S bit row 0. I am connecting it at port 1, right? We are connecting it at port 1. So port 1 0 at the pin. Similarly, I will write it for 7. R0, R1, R2 and R3, column 0, column 1 and column 2. So we are using 7 pins for this. Now whenever you are clicking here, all these are interconnected. Okay. If I can find out keypad image, I'll just show you how they are interconnected, how these switches are interconnected. I don't have digital pen actually, so it's difficult for me to draw on that, use that whiteboard. Now you are able to see this keypad program. Keypad?
Yeah.
Now see here, what we are doing is we are connecting. You are able to see the switches, right? 1, 2, 3, 4, 5, 6, 7, 8, 9.
Yes.
Right? Each column, 1 pin each column. All the switches are connected to power supply.
Okay.
Okay. And the other side of the switch is connected through ground. All the rows.
Okay.
All the rows are connected through common ground. All the 9 rows are connected to common ground.
Okay.
Okay. And all the columns are not connected through power supply, but each column is connected to common power supply. What I mean is R1, R2, R3, R4, all the 4 rows have common ground. That means all the rows are connected through common ground. 1, 2, 3, 4, 5, 6, everything is connected to common ground.
Okay.
But when you say column, you are saying common power supply only. But column 2, 1, 4, 7 are not connected to 2, 5, 8.
Yeah.
Right. 1, 4, 7 are connected through common VCC, but 1, 2, 3 are not connected.
Okay.
You understood what my point? Here you are connecting one pin, one side of the switch to ground. All the switches are connected through common ground. But
Okay.
when you are saying power supply you are connecting through common column.
Okay. Yeah.
Okay. So now what happens is you have to select one column and see that any of the switch in that particular column is grounded or not.
Okay.
The same thing we will do it for column 2 as well as column 3.
Okay.
Or you can do it other way around, that connect all the rows to power supply and ground all the columns.
Okay.
It is up to us.
Okay.
You understood the concept here?
Yeah. Yeah.
Okay. So what we will do is we will ground one row at a time and we will give power supply to one column at a time.
Okay.
Or we will give power supply continuously and just we will ground one row and we will see what happens.
Okay.
So we will start writing program. So first we'll use this keypad function. I'll write one keypad function here now.
Okay.
So first of all, we will have to check for this column. So we will first make our we will do it for continuously. Okay, we will do it only once first and then we will do it for continuous checking. So what we will do is we will make our row equal to 0. Okay, why we are making this row equal to 0? Why? Because here we have seen that we are giving it through common power supply or common ground, right?
Yeah.
Right. But in our Proteus design, we are not going to connect it directly to power supply or ground. We are going to connect everything through port pins. That means if we want to ground some row, we have to make it 0. If we want to give power supply to some row, we will be writing it as 1.
Yeah.
Right. So what I'll do is, here I'll do one thing, that I'll make my row 0 equal to 0. I'm giving my row 0 equal to ground. And then I'll write my row 1 equal to ground, row 1 equal to 0, row 2 equal to 0, and then I'll give my row 3 equal to 1.
Okay.
Okay. Now only for one particular switch we are giving 1. Okay. Now that means what? Here this row 3 or row, I have written it from row 0 to row 3. So this particular pin is connected to power supply.
Okay.
Okay. So when this is connected to power supply, I will have to check for column 1, column 2 and column 3.
Yeah.
Right? Whether it is 0 or not. Because R3 is 1, the other pin has to be grounded.
Okay.
Right. So I will check like if my Column 1, why I am writing column 1 is here because I will have to write one more line if we give power supply to columns.
No.
So that's why I am writing it like call. For rows I am giving only one, and I'll have to check only for 3 columns because we have 4 rows. That's it. If C1 is equal to 0.
Okay.
Okay. Now when C1 is 0 and R3 is equal to 1. When C1 is 0 and R3 is equal to 1, that means this is the particular switch which is activated.
Yeah.
Star.
Okay.
Why? Because we are giving C1 as ground and only R4 we are giving power supply.
Okay. Yeah.
Right. R4 is connected to power supply, and if C1 is grounded, that means in this particular switch power is flowing, or this is shorted.
Okay. Yeah.
Right. Similarly,
yes.
If we say R4 and C2,
0,
which means 0, and C3 R4, which is hash.
Okay.
Okay, that means if C1 is equal to 0, what I want to do is I want to display the same thing on my LCD. Okay, what I want to display on my LCD is simply I want to display that. I'll give one command, LCD underscore command. No, sorry, yeah, command underscore LCD is our function. Command underscore LCD, I want to display it at 0x85 position. What I want to display is your data underscore LCD. I want to display single quote idea single quote star.
Okay.
Right?
Okay.
Okay, here I will write one more command. Why? Because it will not clear it again otherwise. So LCD, okay, I'll write my clear command there whenever I am calling my keypad. Okay, not a problem. So similarly, I will have to write this particular thing for 3 columns.
Yeah.
We have 3 columns, right?
Yes.
So I'll write like Control C and I'll just copy it. If C2 equal to 0, then it has to display 0.
Yeah.
And if C3 is equal to, we have given C0, C1, C2 or C1, C2, C3. I'll have to check once. We have given okay, we'll give C1, C2, C3 because I have written program for C1, C2 and C3. Okay. So here we have C1, C2, C3. So when C3, if C2 equal to 0, if C3 equal to 0, it will display hash. Right?
Yeah.
The same thing now I'll copy it 3 times more. I'll change it then. Here I'm making my R3 equal to 0 and I'm making my R2 equal to 1.
Okay.
Okay. So when my row 2 is equal to 1, it will has to display the first column is 7.
1. Yes. 8.
And this is 8. And this is 9.
Okay.
And here again I'm making my R3 as 0 and R2 as 0 and making R1 equal to 1. Row 1 I'm giving power supply. Okay. So here it becomes then 4, 5 and 6.
Yes.
And the last one is your row. Oh, I have not copied it 3 times, or I am writing it double time. Star hash zeros. Oh, okay. Here I have not. Just make this. And this is your last one.
Okay.
I'm making row 0 equal to 1 and then row 3 equal to 0. So here this becomes 1, 2 and 3.
Okay.
Fine. Now this is our program, so we will have to call this now. First of all, I'll declare my function. We have missed something. Okay, no problem. We will see that also.
Okay.
So I will have to call my keypad. Now I'll call my keypad here. Now what will happen is, as we have not written any condition, what it will do is it will call keypad function, no doubt, but here we are writing only if statements, right?
Yeah.
We have written only if statements in our else keypad function.
Okay.
Right? So if our keypad function, what will happen, if at all if we don't click on any key, it will simply come out of that too within that particular time. So we will have to write one condition that till you return the value, don't come out of it.
Okay.
So what we will write here is, I'll take one variable, and here I'll write that condition. Actually we are displaying directly, otherwise we can display it there, and here we can write simply return function, like return 1, return 2, return 3. That's it. Here in place of this, I'll simply write return star. But this also, if at all here, then what will happen is, here I'll write one variable, some C is equal to keypad, and then we will have to display that on LCD. So we will write it like, I'll take this command and I'll display it in second line. Such that what will happen is, it will wait for us to return something, print underscore LCD. What I'm writing is C. Is it okay?
Yeah.
Till it returns, it will not. So here also I will have to change the statement. Okay, but first we'll just do it. You at least you have an idea, right? Oh, but if I want to. Sakari, install that software?
Just a minute, I'll check. I think no. I think this is not installing.
1, 2, 3, 4. Keel is working properly?
Yeah, keel is working.
Okay, so this is our program now. We will check do we have any errors in this. We do have errors. So here the error is okay near C1, C2 I have written. Now C is undefined identifier obviously. So here I am taking one character as I am returning undefined. Okay. Int C data underscore missing data underscore LCD print underscore LCD. Okay. Fine. Not very exit path returns a value. Okay. Why it is showing not every exit path returns a value is because if at all, if all this condition fails, there is nothing to return.
Okay.
Okay. So that's why it is showing here. So what I'll do is here I'll write here while of 1 and we will see what happens here.
Okay.
Such that my keypad is working continuously.
Okay.
Whether it will throw any errors or not, we will see now. That warning has been hex file. Sorry, this is our, now we will have to connect all the pins first. Okay, so our pins are like row 0 is connected to P1.0. So this is our 0. Okay, you can do one more thing here. You can not necessarily, you will have to connect it through wires only.
Okay.
You can here actually point here. You can edit the properties and say that which path value you are connecting to it.
Okay.
Path reference you can say here if you want.
Okay.
Okay, but I will connect it such that it is easy to understand. So this is my row 1. I am connecting it here. And row 3. And here don't worry about this crossing the wires, because as this is a simulation software, nothing to worry.
Okay. Okay.
Row 0, row 1, row 2, row 3. Oh shit. Okay. I'm so sorry. Now here we have displayed embedded actually. We didn't delete this line, that's why it is showing, and we have not even cleared the screen. Okay, now if we don't clear the screen, how it is going to display the characters? Just check this out. See, 7. We have connected it the other way. We have not.
Okay.
When you are connecting, we are not giving any delay actually. We are not.
Okay.
It is displaying it continuously. So I'll just do one thing. I'll just comment all these things. Because it is scanning very fast, it will scan our character and then it will go to other characters. So it is taking time to display. But we are not giving that time here. So what I'll do is I'll simply pause all these things and I'll give some delay here. Don't pause, nothing will happen. But still I'll give some delay such that it is easy for us to understand. Delay of 100. Okay. Now if we give more delay, there is again one more problem. Sometimes we click it, it will not display because of delay, and then we will click on some other characters till that time. Okay, so we will have to just check out proper delay for that. Now if we click, nothing is going to display. Now if I click on 1, okay, I have connected it other way. This D has to be connected to 1.
Okay.
See, I have connected it wrong way. Columns and rows.
Okay.
We are not giving any, still it is doing it so fast. Oh, sorry, one more mistake we have done here, and that mistake is after making this and nothing. See, it is taking more delay. Then this is, so I'll just decrease the delay first and we will see once. I'll just give 10. Still the delay is different. If we click on continuously, it is displaying that only.
Okay.
So here we will have to again see that. We will have to change the delay and we will have to. But basic code you understood, right?
Yeah.
Yeah. I think I will have to give you code for whatever programs I am writing, or there is no need. Why? Because I am not saving all the programs, but if you want, I'll just send you all the programs. Why? Because I don't think you will have all the programs without seeing the video again.
Yeah.
First of all, so you want programs?
Yes.
You will need it. Okay. I'll do one thing. I'll just write it in one notepad, or I'll just send this C files to you.
Okay.
Okay, so I'll just change the connections and I'll send you. Or actually here in Proteus I need to change, and I need to change the delay. So we'll change that and I'll send you. But the basic concept you understood for keypad, right?
Yeah.
Okay, so we can go for next topic because today I have to complete more 2 topics.
Okay.
We will have to finish this, otherwise we will be lagging.
Yeah.
Okay, so this is with keypad, and next we will have timers. Okay, now what are these timers concept here? Here why we are using timers is because we want to have a particular delay. Now as you have seen that when you are using a for loop, or then you can say that already we have for loop for generating delay. Right.
Okay. Yeah.
We do have for loop for generating delay. Then what is the need of having one more thing? Now you only have seen that when you are writing some particular thing like 1 millisecond delay, or 1 millisecond delay, you are repeating it to generate 1 millisecond, but you are getting 1.3. You are not getting exact delay.
Yeah.
When you repeat it 1275 times, you are getting 1 millisecond. But it is not exactly, when we are calculating, it is not 1 millisecond. It is 1.3 millisecond. That accuracy we don't get with for loop.
Okay. Yeah.
So when you need accurate delays or accurate timings, at that time we need to go for timers.
Okay.
Okay. So for 8051 we have 2 timers. Timer 0 and timer 1. This timer 0 and timer 1 both are of 16-bit timer. They are 16-bit timers.
Okay.
Okay, so you will have something like digit 15, digit 14, and so on till this is your D0 bit. This is your particular, you can just assume it like one box with 16 digits.
No.
Okay, I will have to show that also. Why? Because I will just a second. D13, D12, D11, D10, D9, D8. Otherwise I can use it for D8, D7, D6, D5, D4, D3, D2, and D1. Okay, so these are 16-bit timers. In this, so basically we are using timers to generate a particular accurate delay, or wherever options are required to use particular timings or accuracy, we go for these timers. We have 2 timers, T0, T1, both are of 16 bits. Okay. Now when you say 16 bits, here our microcontroller is of 8 bit.
Okay.
Right. So here these things, what they call it like D0, why I have written is because here D15 to D8, which is a higher byte. Right, this is 16 bit. So D5 to D8 is our higher byte, and we call it as timer high 0. Okay. Okay, this particular part from D8 to D15. This is divided into 2 halves, 8 bits and 8 bits. D0 to D7 and D8 to D15. Okay. This whole register is of 16 bits, but we are dividing this 16 bits into 2 8 bits. So we call this D0 to D8 as low register, and digit 8 to digit 15 as high, and 0 is represents timer 0, which represents higher byte, and T represents timer 0. So timer high 0 and timer low 0. Okay. This is from D0 to D0. D7 to D0 is your timer low 0. Similarly, we have timer high 1 and timer low 1.
Low. Okay.
This is for timer 1. So we have
Yeah.
two timers which are of 16 bits, D0 to D15, and there again that timer is divided into two halves, which we call it as timer high 0 and timer low 0, timer high 1 and timer low 1.
Okay.
Okay, so here these registers are controlled through a register. Again, these two registers are controlled through one more register, and that register we call it as T. Okay, this T mode register is of 8 bits. Now, what this T mode register contains? This timer can be used as counter also.
Okay.
Okay, so we will be selecting either we are using timer 1 or timer 0, and if we are using timer 1 or timer 0, what we are making it used like, whether we are making that timer to work like timer or counter. Okay, or yeah, the other way around, whether the timer 0 is working as timer or counter and timer 1 is working like counter or timer. So this 8-bit register contains first bit as gate bit, and the other bit is C by T, which is counter or timer bit. And what is this mode? I'll say you. Mode 1, mode 0, and the other one is again same bit. This is for gate, C by T, mode 1. Oh, where it is? Sorry. Mode 1 and mode 0. Okay, so this is your T mod register. This register is T mod register, which is an 8-bit register. These 4 bits are dedicated. First 4 bits. This particular 4 bits are dedicated to timer 1.
Okay.
Okay. Timer 1, and this particular 4 bits are dedicated to timer 0.
Okay.
Both the bits are same, but only to say that these are for gate, these are for timer 1 and these are for timer 0. Now, what does this gate bit contain?
Okay.
We are using this gate pin only and only when we are using interrupts.
Okay.
Okay, that we will be seeing when we are seeing your interrupt.
No.
Okay. So what we will do there is, this is for this pin will be high. When this pin is high, like you are whatever serial communication will be using, you are using it for setting high or low. But that I can explain you when you are using serial communication or interrupt. So we will leave this pin for now. So we are using it when you are using gating control for interrupts. Okay.
Sure.
Next we have C or T bit. This bit is used to select whether we are using counter or timer.
Okay.
Okay. Counter is nothing but counting operation. Okay. Just to increment a register.
Okay.
Register in the sense these digits. As this is 16 bit, you will have something like 0 to some number 2 power 16.
Okay.
Next you have M1 and M0. Now this selects mode, the basic operation of your timers. This selects M1 and M0. Now here again this have 4 options, 4 combinations you will have: 0 0, 0 1, 1 0, and 1 1. 4 modes. Mode 0, mode 1, mode 2, mode 3.
Okay.
This M1, M0 bits are used to select the modes of counter or timer. Whatever you use, you will have to use one of these 4 modes. These 4 modes are for M1, M0 combination. We get 4, using these 2 bits, we will get 4 combinations, and we are using 4 modes: mode 1, mode 2, mode 3, and mode 4.
Okay.
Mode 0, mode 1, mode 2, and then mode 3. Now what does these modes contain basically? So here when you say mode 0, this is a 13-bit timer. That means out of this 16 bits you will be using only 13 bits.
Okay.
This is a 13-bit timer or counter.
Okay.
Okay, that means what here? This the timer low 8 bits will be used completely.
Okay.
Right?
Yeah.
Sorry, timer high will be used completely, and timer low, it will be used as a prescaler, or you can say 5 bits will be left and only used when this 8 bits of is overflow. That means once you get 255, then this bit will be incremented. So basically you are using 13 bits out of this whole 16 bits.
Okay.
Okay, that means you will have maximum value of 2 power 13 and not 2 power 16.
Okay.
Right?
Yeah.
Then here mode 2 have 16-bit this is again 16-bit counter.
Okay.
Okay, so this will use all the 16 bits we have.
Okay.
And in mode 2 we will be using 8-bit. 8-bit auto reload. Auto reload is whenever your 8 bits, when you are whatever 8 bits you are using, D15 to D8 or D0 to D7, once it reaches its maximum value, which is FF, it is automatically reloaded with particular value or 00.
Okay.
Okay, so you call it as 8-bit mode, and this is split mode timer, which we will not be using right now. This is split mode. So here you have 4 modes. You can use it for 13-bit, 16-bit or 8-bit.
Okay.
Okay, so depending on this we will have to say that what mode we want. Now the question is how to select and where to say that which mode we need or how much delay we want. So that we will have to calculate. How to calculate that. So but first of all we will see how to select this T-mod register.
Okay.
Okay, now I want to use mode 1 and timer 1.
Okay.
If I want to use this, then how to select this? So my T-mod value now will be T-mod is, so first of all I am using timer 1, right? Gate bit I'll write it as 0 because as I said I am not using any interrupts or anything else right now, so I am not using gate control. So I'll make this bit as 0.
Yeah.
Right? Now I want C or T. I am saying I need timer 1. Right?
Okay.
So C by T counter, if you want to make, this bit has to be 1. And if you are using it like timer, this bit has to be 0.
Okay.
M1, M0 bits, I have to select mode 1 from it. So when I say mode 1, that means I am using a 16-bit timer. So this value becomes 0, 1.
0, 1. Okay.
Right? And I am not using timer 0, so this becomes 0.
Okay.
Right? So my T-mod value becomes 0x10.
Okay.
So when I say T-mod is equal to 0x10, it means I am using mode 1 timer 1.
Okay.
Okay, one more we will write. I am using mode 2 and timer 1. At the same time, I am using mode 1 and timer 0. Okay.
Okay.
So now what happens is, so first of all we have to select the timer, we have to set timer 1. So for timer 1 gate bit is 0, next bit is, I am using timer, so these two bits, this bit is also 0. Now mode is mode 2. For mode 2 my value is 10.
Yeah.
Next to 4 bits timer 0 also I am using, so my gate bit is 0, I am using it like timer, so second bit is also 0 and I am using it in mode 1. Mode 1 means 0 1. So it equates to 0x to 1. Okay?
Okay.
Right.
Yeah.
So in this way you can use your TMOD register to select what operation or which timer or which counter you want. In place of here timer 0, if you want to use counter, so here simply I have to make this particular bit as 1.
Okay.
Right. So this becomes 101 is 5.
Okay.
Okay. So in this way we can select. Now here, now what we have to do is we will have to use our crystal oscillator only.
Okay.
But how to say that? Now first of all we will see mode 1, how mode 1 is working. Okay. So first when we see mode 1, once you, why I am selecting mode 1 is because it is a 16-bit time. Okay, so in mode 1 what will be the value? The value will be 0 0 0 0 is my minimum value and my maximum value is F F F F, right?
Yeah.
Right. Now what happens when you say, when you are initiating your timers and starting from 0 to FFS, it will take that many cycles to increment.
Okay.
Okay, so it will give you that particular delay, but we will have to first see that how to calculate this. Okay, so first what we will do is we will load our value in TH and TL. So at starting if I am writing it with 0 0, so my timer low value which is there in this register, okay, this particular thing, D15, D0 to D15. TMOD value already we have selected. So this is my timer 0 value. In this timer 0 or timer 1, we will load it with 0 0 0, timer low and timer high. And this is like starting point. And after that we will give a signal that start the timer. Once we start the timer, it will increment 0 0 0 1 2 3 4 5 6 till FF.
Okay.
And once it reaches FF, it will show you an overflow.
Okay.
Okay, which means that it has been overflow and our timer has finished that particular operation.
Okay. And
if you want to repeat it, you will have to order that process again.
Okay.
Okay, so but then I will need one more register to say that when, how I will find out that whether this overflow has occurred or not. We have to start the timer. We will have to say that start also. And then we will have to wait for that overflow. In between what is happening is nothing but incrementing. And that incrementing is nothing but our delay.
Okay.
Okay. But for that we need to say our controller that start the timer, wait for the overflow flag, and then again stop the timer.
Okay.
Okay, so that we will have in one more register. One more register will be there in which we can say that here is our what this particular start and stop bit.
Okay.
Okay, and that register we call it as T-con register, which is timer control register.
Okay.
Okay, so this is again an 8-bit register. So that means in timers we have 4 registers related to timer. Timer 0 register, timer 1 register, T-con register and T-mod register.
Okay.
Timer 1 and timer 0 registers are to increment or decrement the particular digits, and then to set the control, start and stop the timer, and then T-con register is for control bits and T-mod register is to select the mode of the register, mode of the timer or counter.
Okay.
Okay, so what does this T-con contain? So here you have again, these are divided into divided into 2 means here you can use it for, you will have 2 bits. So I'll just write it down first. This is TF1, TR1. It is not divided directly 4-4, that's why this is for TR0. Then you have IE1, IE0 and IE1, IT1, sorry, IT1 and IE0 and IT0.
Okay.
Now, what does this bit contain? So basically, these ending 4 bits, the last, or you can say these 4 bits, D0 to D4, right now we are not going to use because these are related to interrupts again.
Okay.
Okay. So while doing interrupts, we will come across this again.
Okay.
So we will, right now we will concentrate only on these 4 bits, which
Okay.
is TF1, TR1, TF0 and TR0. Okay.
Okay.
So what does this contain? This TF1 is, okay, first we will see this TR0. So TR0 is to start the timer. Okay, TR0 is for start or stop the timer. Not only start but to stop also.
Okay.
Start or stop the timer. Similarly, TR1 or TR0, same thing. TR1 or TR0 is to stop or start the timer, and then TF0 and TR0 is for controlling the overflow.
Okay.
These are, we can say it is simply a overflow flag which indicates that overflow occurred or not.
Okay.
Okay, so these are overflow bits. Fine?
Yeah.
Now we will have to see how to calculate this, because without seeing how to calculate this, we will not know how this particular thing is working.
Okay.
Okay, now I want to generate some particular delay.
Okay.
Okay, so first of all, we will see this like, we will start with our crystal oscillator frequency.
Okay.
Now, what we are saying, our crystal oscillator frequency is 11.0592 megahertz.
Yeah.
Right?
Yes.
And when we divide it by 12, which is our machine cycle, we get something like 921.6 kilohertz, something related to this.
Okay.
Okay, but this is again frequency. So when we need time, we will do it like 1 by frequency. So we get something like 1 by 921.6.
Okay.
1 by 921.6. So we get something like 1.085 microseconds.
Okay.
Right? This is our basic calculation which we have already seen.
Yeah.
Right. Now, whenever we want to have it, whenever your timer now increments, like from 0 to 1, 1 to 2, 2 to 3 till FFFF, so that much 1.085 has to be multiplied.
Okay.
Which means number of increments or counts, you can say. It is incrementing, right? Your timer register is incrementing. So number of time it increments, number of counts are incremented. incremented, it will generate into 1.085 microseconds. You will get that much delay.
Okay.
This is clear?
Yeah.
Now suppose I am taking some particular value. I am not starting from 0.
Okay.
Okay, I am not starting from 0. I am taking some particular value like FF2.
Okay.
Okay, now if I say FFF2, how much delay we are, that means it will be starting from FFF2 and it will increment it till FFF, which is how many counts? Which is 13?
Yeah. 14.
My maximum, I am starting from FFF2, my maximum value is FFFF.
Okay.
Okay, basically if it is 10, I am starting from 8, 9 and 10. This is my maximum value. So I am getting 3.
Okay.
So if I subtract from FFF2 minus FFF, I will get something like 13, which is nothing but D.
Okay.
Right?
Yeah.
Now what happens is once you reach FFFF, it will have an overflow.
Yeah.
Okay. Overflow and it becomes 0.
Okay.
Okay. And here one cycle is needed for this overflow and a overflow flag to become high.
Okay.
So whenever we are calculating, we will be adding D plus 1.
Okay.
Okay, which becomes E, which is nothing but 14.
Okay.
So our delay becomes 14 into 1.085 microseconds.
Okay.
Okay, which is something, if we calculate, is 14 into 1.085, which will be 14 point something. So approximately I'll take it like 15 microseconds. I'm not saying exactly, but 14 into 1.085, somewhere around 15 microseconds delay we will get.
Okay.
Right. So this is the way we will be. Okay. And here what happens is, if we write it for, this is only for, this will be only for one pulse.
Okay.
We will have full pulse, right?
Yeah.
One machine cycle will have one high and one low pulse.
Yeah.
So one period, particularly, this is only for half period. This count, this particular thing is for half period. So if we want to have full period, generally we count our delay for full period. So full period is nothing but T is equal to 2 into this particular 15 microseconds or something, 15 change. So I'll get somewhere around 30 microseconds delay.
Okay.
This is how we generate delay in using timers.
Okay.
You understood? You can have any value. But here my problem is, how we will say how much delay, I mean like how I will know I will have to start from FFF2.
Okay.
I don't know, right?
Yeah.
I don't know how much delay I want to generate. I can't say I will have to start from FFF2.
Okay.
You got my point, what I'm saying?
Yes, yes.
I don't know I will have to. I cannot say I want to start from D8, D3 something. I will simply say I need 1 millisecond delay, I need 1 second delay, or I need 13.2 microseconds delay. In this way I will say.
Okay.
So what we will have to do is, we will have to do it in the other way. We have here, we have got frequency and we have converted into time. So now when we have time, we will be converting it into frequency.
Okay.
Right?
Yeah.
One second.
Yeah.
Do you mind if we take some more, I mean like 15-20 minutes?
Yeah, that's fine.
Such that I can just complete this topic.
Okay.
Right. Now, suppose I want to have something like, I want to just now whatever I was saying. Now, what I want is, I want 10 milliseconds delay.
Okay.
Okay. So now what I'll do is, here 10 milliseconds divided by 1.085 microseconds.
Okay.
Okay. So this is nothing but our time.
Okay.
I'm converting it into frequency. 1.085, 1 by 1.085 we will do. But I want to do it for 10 milliseconds, so I am writing 10 by 1.085.
Okay.
What I'll do is, actually what we will do, 10 into 1 by 1.08, right? This is the way.
Yeah.
I have to convert this 1.085 into frequency. 1 by t.
Okay.
I have to do it for 10 milliseconds. That's why I'm multiplying it with 10. So
Okay.
I'll get some number. I will have to divide this. So if I remember somewhere around, I'll just calculate it. I don't remember what number I'll get. Okay, I'm doing it in phone, so fine. So I'll get somewhere around 9216 cycles.
Okay.
Okay, now when I get 9216 cycles, now I will know that my maximum value, which is for 8-bit, is 65536.
Okay.
Okay, I'll subtract this from 9216.
Okay.
Okay, so I'll get somewhere around 56320.
Okay.
That means what? I will have to start from 56320 and I will have to increment this count till 65536.
6. Yeah.
Then I'll get my particular 10 milliseconds delay.
Okay.
Fine. Why I have written, I know that